Hi there, welcome back to another video on the Data Wrangling 101 YouTube channel. Retailers lose billions to returns every year. Today, I'll show you how to spot the leaks before they drown your margin. Building a machine learning model in-house may need a high degree of data science expertise or may need expensive software, but we'll build a lightning fast analytics workflow in KNIME using a tiny dash of ChatGPT to classify return reasons without the need to create a specialized machine learning algorithm. The goal of this video is to use KNIME to analyze the orders data and the return data. Let's take a look at the workflow architecture. The workflow is divided into four major areas. As a first step, we will load the data from CSV files. We have order data and returns data, two data sets in CSV files. As a first step, when we load them into KNIME, we are going to see if they need any cleanup. If they need cleanup, we'll perform the cleanup using the nodes available in KNIME as a data preparation step. Next, we will join the orders data and the returns data as an inner join using the order ID and the SKU number. That gives us a mapping between an order and a return that corresponds to that order. Our return data has specific reasons provided by customers for why they want to return the product. The reasons are in a text sentence format. In the next step, in the classify step, we are going to use ChatGPT to classify the return reasons into specific categories. We are also going to use a chunking node in KNIME to reduce the cost of the API usage by only sending 20 products at a time to ChatGPT. As a final step, we are going to calculate some important KPIs and create a few visualizations to help visualize the output. The classification that we are asking ChatGPT to do takes a return reason in the form of a sentence provided by a customer at the time of return and categorize that into a specific category like defect. The prompt that we are going to send to ChatGPT is something like this. You are an e-commerce return reason classifier. We are asking ChatGPT to play a role and then we are specifying the output that we want from ChatGPT. We are asking ChatGPT to give us the output in a JSON schema and we are asking ChatGPT to pick one of the following specific categories for return. So it could be sizing, defect, late delivery, buyer's remorse, wrong item or other. The other category is used in cases where ChatGPT doesn't know how to classify a particular reason provided by a customer. This prompt will also include the actual reason that we received from a customer. On the left, we have the orders data. We have order ID, customer ID, order date, sales channel, SKU number, quantity, unit price, and a promo code where applicable. On the right side, you'll see that we have the returns data. The returns data also has order ID, SKU number, return quantity, return date, and the return reason. The return reason, as you'll notice, is feedback provided by customers in a sentence describing the reason why they want to return the product. Let's read in this data and go to the next step. To save some time, I've already performed some of the steps beforehand and you'll see that I have my orders data and the returns data already loaded into KNIME. On the returns data, I want to perform a cleanup. So I'm going to bring in a missing value node and my configuration for the missing value node is as follows. For string, if a value is missing, I want to replace it with this text unknown. And if a number is missing, I want to do nothing. But if a local date is missing, I want to remove the whole row because local date, the return date is very important for our analysis. And I'll run the node to prepare the data. Next, we are going to join the order data and the return data. The join operation will be done using order ID and the SKU number, because we want to analyze down to the SKU level, order and SKU level. I want to compare values using string representation, and I only want to include matching rows. I don't want left unmatched and right unmatched. This is going to result in a inner join. I want to include all the columns in my order data, but because I have order ID in SKU, which is my joining criteria, I will exclude these from the joined output from my returns data. Click OK, and when I run this node, you'll see that my inner join results in 1193 rows, whereas my order data had 10,000 rows and my returns data had 1193 rows. And that's why my join output as an inner join only has 1193 rows. As a first step, I want to calculate the time difference between an order date and the corresponding return date. I will do that using a date and time difference node. My configuration for that is the base column, I want that to be the order date. My second column, I want it to be the return date. Granularity will be at number of days, and I want the name of the column to be days to return. Executed, you'll see that I have a new column called days to return, and this shows me the number of days between the order date and the return date. Next, I want to calculate a few more metrics related to the order value and the return value. I will do that using a expression node. My first expression is going to be called order value, and this one is going to be my order quantity multiplied by unit price to give me the value of each line item in an order. Next, I want to calculate the return value. And this one will involve return quantity multiplied by unit price. And finally, I want to calculate the rate of return by quantity. For each line, return quantity divided by order quantity. This one will give me, for each line item on an order, what percentage of products were returned. Click OK. So this gives me three new columns: order value, return value, and return rate. As a final step, I want to exclude any return that took more than 60 days. I will do that using a row filter node, and my criteria will be days to return less than or equal to 60. And I want to output only those rows that match this criteria. Now I am ready to move on to the next step and send the prompt to ChatGPT to do the classification. Like I mentioned earlier, the prompting will be done in chunks of 20 lines or 20 rows at a time. So I'm going to connect my row filter to the chunk loop start. My chunk loop is 20 rows per chunk. The prompt that I'm sending to ChatGPT looks like this. The system message says, you are an e-commerce return classifier, specifying the role that we want ChatGPT to play. And further, the instructions to ChatGPT are to create a response in a JSON schema using the format specified below and the categories specified below, which are sizing, defect, late delivery, buyer remorse, wrong item or other, followed by return reason, which is in the return reason column, which we'll use as the prompt column. And we want the output to be in a column called category. And finally, we will click OK and run the prompt. The other thing that needs to be done before you can run the prompt is to specify your API key, connect that to an OpenAI authenticator, and select an OpenAI chat model, which in our case is the GPT 3.5 Turbo. The temperature that we are setting for this prompt is 0 because we don't want any creative classification. We want a very deterministic response. Our final process data is 1,000 odd rows, and we are chunking these 1,000 rows into 20 rows at a time. And when we run the LLM prompter through this chunk loop, every time 20 products or 20 rows are going to be sent to the LLM prompter for it to do its classification and give us a return data. Because we are chunking into only 20 rows at a time, the actual cost of this calculation by ChatGPT comes out to around 3 cents per 1,000 rows. Because we are sending the prompt to ChatGPT 20 rows at a time, this takes a little bit of time to run the workflow, around 15 to 20 minutes to process through the whole 1,000 rows. So I have already done this, and we'll look at the output from the classification. Let's take a look at the classification done by ChatGPT. As an example, if the reason given by a customer is changed my mind after ordering, ChatGPT has classified that reason as buyer remorse. If the reason provided by a customer for returning a product was headphones stopped working after one use, ChatGPT has classified that to fall in the defect category. If the reason provided by a customer was too small for me, need a different size, ChatGPT has classified the return category as sizing. Next, let's do some visualization of the output data. Using group by, I've done some KPI calculations of this output. We see that of all the returns that we have, the majority of the returns have reason in the buyer's remorse category, followed by wrong item and sizing and defect, and finally late delivery. We also see the return value by each of these categories, and we also see the corresponding order value for each of these categories. Let's do some more calculations. Using more expressions, I now have a net sales sum. Given the total order value of 72,000 for all products, for all orders that had returns under buyer's remorse category, we see that the net sales end up being 20,000 with 71% of the products being returned. Let's also finally visualize some of this data in the form of bar charts. This chart gives us the count of SKUs and the reasons for their return. So buyer's remorse seems to be the reason for the highest number of SKUs, followed by wrong item and the defect and sizing, and finally late delivery. For each category, a comparison of the order value and the money lost in the form of returns. So buyer's remorse seems to be the largest category of returns for the products in this assortment. And finally, let's take a look at the number of returns by month. So this line graph shows the months which had the highest number of returns. For example, you had lots of returns in November, April, January again, June, and finally May. And the lowest returns happen in the month of September, August, and July. You can now hand the KPIs provided by the workflow back to your finance team or push it to Power BI. Your call. If you'd like to explore this workflow more, grab the full KNIME workflow and sample CSV links in the video description below. If you found this useful, let me know in the comments. And if there's a particular retail analytics problem you'd like to see solved using KNIME, let me know also in the comments, or reach out to us by email at contact at datawrangling101.ca. Thank you and see you next time.